Okay, I'm trying to get all caught up here. We are on a roll. This is the fourth movie of the night, the third one for geometry, the using perpendicular bisectors. So, if you want to do this review, you can. I'll freeze this, or you can freeze this, and I'll pull these away. That should not be a problem. Okay, so a segment intersects, and I don't need that extra line there. Segment bisector that intersects a segment at its midpoint and is perpendicular is a perpendicular bisector. And talk a little bit about these theorems. So the perpendicular bisector theorem says that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So CA is going to be equal to CB because CP is the bisector of AB. And the converse of this says that if a point I tell you is equidistant from the endpoints, then it is definitely on the perpendicular bisector. So if you look at CP, they're going to say, well, CP is a perpendicular bisector, continue and go through point D. But in order to figure that out, they tell you that DA is equal to DB. So since they're equal, this line continues. Yes, it has to go through D, so it's on the perpendicular bisector. So we're going to use the perpendicular bisector to solve some problems. Okay, I'm going to actually just go through these guided practices with you. Okay, so in the diagram, they tell me that JK is perpendicular bisector. So which segment lengths are equal? So that tells me, well, first of all, this segment must be equal to this segment because it's perpendicular bisector. Okay, you can see by the 8 here that this segment is obviously equal to this segment. That also tells me that M must also be on the perpendicular bisector. And it also tells me since K is on the perpendicular bisector, KN has to be equal to KL. So that tells me that 6x minus 5 has to be equal to 4x plus 1. They don't ask me to solve this, I don't think, but I actually can. 2x minus 5 equals 1. So 2x, add 5 to both sides, equals 6. X equals 3. 3 times 6 is 18. 18 minus 5 is 13. 3 times 4 is 12, plus 1 is 13. So they are equal, and that's my reasoning. Okay, in the diagram, find the value of NK. Oh, I think we just did that in the last problem. We did, so it's 13. Okay. In the diagram, but we also talked about that already. M is definitely on the perpendicular bisector of JK because M is 8 spaces from N and it's 8 spaces from L. So that's the converse of the perpendicular bisector. We didn't do this activity. We have a project that we're working on. And we did talk about the angle bisectors. Sorry, I said angle bisectors, perpendicular bisectors. I hate this chart. So that's a perpendicular bisector, that's a perpendicular bisector, and that's a perpendicular bisector. They're going to intersect at the same point. That's called the point of concurrency. And that point of concurrency to the vertex, these segments are all going to be equal. Okay? Now also, this point of concurrency, they show it later, is called the circumcenter. I wish it was right there with what we just talked about. So I'm going to talk about this. So this point of concurrency, these are the perpendicular bisectors, meets in an acute triangle inside triangle. It meets in a right triangle on the hypotenuse of the triangle, and an obtuse triangle outside. Since these vertices are all equidistant from this center, from this point of concurrency, the circumcenter, you can actually make a circle that uses the circumcenter as its center, and the triangle is what's called inscribed inside of the circle. Okay? So think we did this daily homework quiz in class. We're going to go through this now also in case you want to. These are going to be equal. So why am I losing control here? Okay, so 3x plus 1 is going to be equal to 4x minus 7. I add 7 to both sides. That's 8. I subtract 3x, that's equal to x. And so the length of AB, 8 times 3 is 24, plus 1 is 25. Next problem. 5x plus 7 is going to be equal to 7x. So 7 is going to be equal to, is that right there? Let me see here. So subtract 2, 5x is equal to 7 halves. That's what I come up with. Okay, so 7 times 7 over 2. 7 times 7 is 49, divided by 2 is going to be 24.5. And in this diagram, find the perpendicular bisector. Okay, in this diagram, the perpendicular bisectors meet at G. Find the length of EC and GC. Okay, well, since this is a perpendicular bisector, it's going to bisect this line in the middle. So if BE is 5, EC is 5. And if B to G is 7, then G to C is 7. Also A to G is 7. I think we talked about this in class. I could also, if I wanted to now, find the length of this perpendicular bisector. Okay? So I'm going to do that. This is going to be 5 squared. 5 squared plus what I'm going to call B squared is equal to 7 squared. So that's 25 plus B squared is equal to 49. Subtract 25 from both sides. B squared is equal to 24, which means that B is equal to the square root of 24. If I wanted this routed to the nearest hundredth, I would put it in a calculator. But if I wanted simplest radical form, think of the factors of 24 are 6 and 4. 4 is a perfect square. Pull it out and get 2. Factors of 6 are 2 and 3. There's nothing more I can do. So the length of GE is 2 radical 6. This one here, okay, this is 7. I don't know how long this side is to be able to determine that, okay? Because the perpendicular bisectors are not equidistant from the circumcenter. It's the vertexes that are equidistant from the circumcenter. So that's at 7, that's 5, and that's 5. But at this point, I do not have enough information to find these other missing segments. But I can go ahead and do my homework. Should probably cover that up for you. But you can go ahead and do your homework. Okay? Thank you for watching the video.